In today's lesson, we are going to talk about the continuation of permutation. But before then, let's review what we did in our previous lesson. In our previous lesson, we spoke about permutation and its application. Then we touched a little on combination. We said combination and permutation, the main difference between them is the order of arrangement. Combination does not consider the order of arrangement, whereas permutation considers the order of arrangement. Then we proceeded to talk about the branch of mathematics that deals with or that involves this concept permutation and combination, and we said that branch is combinatorics, and we said combinatorics deals with counting, arrangement, and then how objects are combined. Then we proceeded to talk about permutation. It's an arrangement of objects in a specified order. So when it comes to permutation, the arrangement is very, very important. Then we proceeded to talk about some key characteristics that will help you to identify if a question is permutation or not. Then we said the first characteristic is the order. If the order is involved, then it means that that question is a permutation question. So we described or we used ACB and then ABC as example. You realize that their relative positions are different. Their relative positions in each event is different, and then no object is being repeated. Secondly, we spoke about no repetition. Now, unless specified in permutation questions, unless specified, you do not have to repeat any object. No object is repeated unless the question is demanding that you repeat. And anytime that repetition is allowed, it means that a different formula, which we shall be talking about later in the video, should be used. Then we proceeded to talk about the formula for permutation where repetition is not allowed. So we said that this is the formula for permutation where repetition is not allowed. Take note. And then we said that this is how to denote permutation, and then also this is how to write the formula. N stands for the total number of distinct objects available, and then also R is the number of objects to be arranged or selected at a time. And then factorial. When we say factorial simply means the product of all positive integers that are equal or less than the given number. So if I have 5 factorial, all positive integers equal or less than 5 are 5, 4, 2, 3, up to 1. Those are the positive integers. Then we proceeded to talk about some applications of permutation. We spoke about how objects are arranged in sequence or lines. So here we said that we have 3 balls, A, B, and then C. Now in the first choice, you can either select A first or B first or C first. So there are 3 possibilities. Now when one of the balls is selected, it means that the second possibility is going to be true because you are left with only 2 balls. And then when one is also selected in the second possibility, it means that it's left with only 1 possibility. Therefore, you have only 1 chance of selecting just that 1 ball. And this is 3 factorial. So 3 times 2 times 1. A total of 6 ways in which the 3 balls can be selected. So it is very important anytime a question is identified as a permutation question, look at the number of objects. So if the objects are 10, start from 10. So let's say you have 10 objects, and then you are required to find the number of different ways that those 10 objects can be arranged. It means that just take 10 factorial. If there are 5 objects, take 5 factorial. If there are 2 objects, take 2 factorial. That will give you the number of different arrangements that those objects can be arranged. So we proceeded to also talk about some examples under the application. So here we have 4 books. So as I said, you realize that here there are 4 books, and then we are required to find how many different ways they can be arranged. Since there are 4, we started from 4. So 4, 3, 2, and then 1. So always start from the highest number factorial, then you can get your answer if it is a permutation question. So we saw some examples here, and then from what we have done, another application that we spoke about was creating of codes and then passwords or numbers. Yes, in our car number plates, they employ the application of permutation, and then also in our phone numbers. Yes, because the arrangement is very, very important. Anytime you change a number, you realize that you basically go to a different user. The call goes to a different user on the same network. Then we talk about also constructing codes. Yes, you realize that here the codes are different. So you realize that anytime you have a code, you can't repeat the code. Anytime you change a letter or even a number in the code, the whole code changes. So we spoke about that, and then we also give an example where we said that a car plate consists of 3 different letters followed by this. So followed by, we shall talk about that later, because anytime you have a number in sequence, so this is sequence because you realize that after this 3 is that. So what counting principle can we